How a CPU works, a simplified overview. A central processing unit, CPU, is often referred to as the brain of a computer because it executes instructions, processes data, and manages operations necessary for computing tasks. Here's how it works. 1. Basic components of a CPU. Control unit, CU, directs the operations of the CPU, fetching instructions and managing data flow. Arithmetic logic unit, ALU, handles mathematical operations, addition, subtraction, etc., and logical comparisons, and or not. Registers, small fast storage locations within the CPU that hold data temporarily for processing. Cache, high-speed memory inside or near the CPU to store frequently accessed data. Clock, coordinates the speed at which instructions are processed. 2. Key processes in the CPU. The CPU executes tasks in a cycle known as the fetch-decode-execute cycle. A. Fetch. The CPU retrieves an instruction from memory, RAM, at an address specified by the program counter, PC. The instruction is stored temporarily in the instruction register, IR. B. Decode. The control unit interprets the fetched instruction to determine the operation, e.g., addition, data transfer. It breaks down the instruction into signals understandable by the CPU's components. C. Execute. The ALU performs calculations or logic operations as required. For non-ALU operations, such as data transfer, the control unit directs the data to or from memory or input/output devices. 3-point CPU performance factors. Clock speed. Measured in gigahertz, it determines how many instructions the CPU can process per second. Cores. Modern CPUs have multiple cores, enabling them to handle multiple tasks, threads, simultaneously. Cache memory. Larger caches reduce the need to fetch data from slower main memory. Instruction set architecture, ISA, defines the commands the CPU can execute, such as x86 or ARM. 4. Parallelism and pipelining. Parallelism. Multi-core CPUs allow multiple processes to run concurrently. Pipelining. Overlapping the fetch, decode, and execute stages for multiple instructions to improve efficiency. 5. Modern enhancements. Hyper-threading creates virtual cores to enhance multitasking. Integrated graphics. Some CPUs include GPUs for graphics processing. Energy efficiency. Modern CPUs balance performance and power consumption for various devices. In essence, the CPU takes data, interprets instructions, and processes it to provide the output we see on a device. It's a highly sophisticated, yet remarkably fast component that makes computing possible.